Firstly, please join me in welcoming on stage Shri Prithviraj B.P. IAS, Additional Commissioner, Pune Municipal Corporation, Government of Maharashtra, to deliver a keynote address. Shri Prithviraj B.P. is an IAS officer of the 2014 batch belonging to the Maharashtra cadre. He has served previously as the District Magistrate and Collector of Latur, and he has also served in other capacities such as Sub-Divisional Magistrate and Project Officer ITDP and Assistant Secretary in the Ministry of Coal. And currently, he is the Additional Commissioner of Pune Municipal Corporation. Please welcome him with a big round of applause.
Firstly, let me thank APAC Media for inviting Pune Corporation to deliver a lecture in this session. I'll also like to welcome Dr. Kailash Shinde. He is the Municipal Commissioner, Navi Mumbai Municipal Corporation. Together with Shri Nikhil Bagalkotkar, who is the Director Autodesk, and all respected dignitaries from Government of India, Government of Maharashtra, various departments, and friends. Everyone knows that water scarcity is going to be a big challenge in the times to come. If you look at some of the statistics, the world can lose up to 6% of GDP because of water scarcity. Government of India has undertaken massive programs for water and sanitation. You might be aware, Jal Jeevan Mission is there, Amrut scheme is there, and for sanitation, Swachh Bharat, which everyone is aware. So we are spending close to $200 billion to ensure that our citizens get equitable water, equitable access to water, sanitation, and basic services. So friends, coming to the specific topic, which is how do you build resilient water ecosystems with the usage of various technologies that are there in the market today. So I'll be speaking basically about the projects which we have done in Pune Municipal Corporation. So friends, what is the main objective of any water supply scheme for a big city, big corporations? And what is the importance of corporation? I'm sure everyone knows that India is urbanizing. We are already 50% urban. If you look at Pune district, almost 80% of the population of Pune district, ते PMC आणि PCMC हा दोन कॉर्पोरेशन मध्ये राहते. आणि जर एरिया बघितला तर that area is just 20% of the entire district. म्हणजे 80% population is living in 20% space. So this is common everywhere. This is happening across India. So how do you cater to the challenges which are raised in such urban environments? And what are the objectives of, if you look at specifically the water supply scheme? First objective is obviously to ensure that the service quality of water supply is good. We need to ensure timely water supply, adequate water supply to all the citizens in the city. That is the first part. And together with this, because of the water scarcity, climate change issue, we also need to look at how do you reduce the non-revenue water. So non-revenue water, unaccounted water, basically in all the cities across India, I think around 30 to 40% is the general norm. That is what we consider the loss due to distribution losses, due to leakages, due to unmetered water which is flowing. So how do you reduce that in the light of challenge of water scarcity? So obviously technology can provide a lot of solution in this. Citizen participation in another aspect. You take it from the big reservoir, then you go to the treatment plant, then you go to the distribution, and finally to the consumers. So let me start from that part, like what technologies we are using and how that has helped us. So one interesting thing in Pune is that Pune is a saucer-shaped topography. So you have the topography which helps in the sense that we are using the gravity to pump almost 40% of water, and only 60% is what is being, electricity is being used. So it gives a natural advantage that the amount of electricity we are using is very less. Recently, we have started using EM flow meters, what you technically call as electromagnetic flow meters, in all the pumping stations, in all the lifting setups. The idea is to get an accurate idea of how much water we are lifting and where is it going. So the old flow meters were something called insertion type EMs, but anyway, we are past that. I'm sure most of the people are using EM flow meters nowadays, and it is obviously connected to technology, to online portal, so where we can real-time monitoring is done, how much lifting is happening. Next comes the processing part, which is the water treatment plants. So there also, of course, we have the flow meter to understand how much water that we have lifted is actually coming to the WTP, so that there is no loss in between in the trunk line. There are various technologies for WTP, and slowly people are moving to what is called as ZLD, zero liquid discharge plants. In normal conventional WTPs, around 4 to 5% of water is wasted because of the processing. But then, as everyone knows, that we need to save each and every drop of water. So the new technology which is coming up is zero liquid discharge, in which this 4% loss is also minimized. So two of the water treatment plants in Pune, they are zero liquid discharge plants. One is 500 MLD at Parvati and the other is at Bhama Skate. And another interesting thing that we have done in one of the WTPs is we are using something called membrane technology clarifier. Now, what is this and what is the advantage? In plain language, the typical technology, the area that it uses, normal WTP, the area that it uses is quite large. And in a city like Pune, Mumbai or any other big metro, you have a scarcity of land. So this helps us in having the same capacity of plant in 1/4 area. So that is the technology we have started using, and I think very few plants all across the country are using such type of technology. Coming to the next part now, which is the water supply. Most people are doing the automation, but distribution, we think that some of the interesting things Pune is doing, which can be replicated in other places. So what we have done is we are trying to have localized water tanks in different water zones that we have created. Why do we have so many water tanks? Because, as you know, the distribution losses are always more if your distribution network capacity is more. So to minimize it, we are having almost 80 or 82 localized water tanks in different zones, so that the tank can supply locally and the distribution loss through the tank to the consumer is minimized. Obviously, this helps in reducing the overall non-revenue water leakage. Also, what we are doing is the water meters, everyone is aware, AMR, automatic meter readers, everyone is using, but there are 2-3 technologies in that. So one is, of course, the walk-by system, wherein the person with the reader, he goes near the meter and he captures the value. Another is, or he personally walks, or sometimes the vehicle also goes along the road and the data is captured. Another interesting thing is something called fixed network gateway. So in that, you don't need to go manually to those individual meters, or even the vehicle doesn't need to pass in the nearby area. Automatically, like a mobile tower, you have a receiver, and all these meters, they will send the data directly to the central system. Why is it helpful? It reduces your manpower cost. It gives you real-time information at any point of time, and it is more robust. One interesting thing that we are doing, which is probably not done in a lot of places, is something called machine-to-machine transfer of data. So normally AMR, people go there, they read, they put in the values, sometimes manual intervention is there, and it might lead to sometimes wrong readings, or in the sense that there can be collusion between the reader and the consumer, and you might not get the true values. So what we're doing is totally automatic. The data goes from the AMR to the reader, and from the reader goes to the server. So there is no human intervention as such. He doesn't need to enter anything in that. The machine data automatically goes through this finally to the server. So there is absolutely no human intervention in terms of any kind of fuddling or fuzzing of data, and the correct value gets updated in the server. Friends, to ensure that all these technologies, we have a centralized command and control center. There are different 5 command and control centers. Some we have already set up, some we are in the process of setting it up, and there is a centralized command and control center. So how we are using all this technology, smart meters, flow meters, and now ground penetrating radars, and nowadays you even have AI coming in this. So how overall, how do we use it? So very simply, 2-3 minutes I'll tell you about it. So when you have the data from all these different systems coming in, you need to analyze that data in various terms. So one is of course the trend. Normally, what is the flow of water in a particular area? If it goes up or down in some days, some instances, then there is a need to be alerted. So there is automatic alerts that we have put in the command and control center that this is the trend. Any deviation from the trend in terms of flow meter of any kind of flow meter, the bulk flow meters or the individual flow meters, if there is any deviation, then alert goes to the operator, alert goes to our people, and we need to investigate what has happened. It can be a leakage or it can be something else that we need to investigate. So this reduces your manpower because mechanization is happening, automation is happening, and you get to know only the critical parts where your intervention is needed. Another thing what we are doing is when we are getting the data, this is the water we are supplying in a particular zone, we are using a software, something called Smart Era, and it analyzes that this is the water which is coming, this is the population data, and that simulation we are doing through digital twin, that in this particular area, so many societies are there, so many commercial establishments are there. So tentatively, what should be the usage? And you have the data from the actual meter. Then you can analyze using the AI and other algorithms whether the flow is correct or not, whether some investigation needs to be done because the consumption is on the higher side. Once you have a broad idea, yes, this is the area where we need to investigate because the water which is coming in and water which is being utilized, the theoretical figures, they don't match. Then you can use the technologies which people are aware, like you have those robots which you put inside the pipelines to find out visually what leakages are there. You also use something called the acoustic technology, which finds out what is the leakage or where is the leakage depending on the pressure in the pipelines. There are a lot of challenges in these technologies, but what AI and these things are helping is to narrow down the area where you need to investigate the problems. Otherwise, it's very difficult manually to go in a wide area and find out what is the leakage, where is the leakage, what is the issue. The other thing is regarding the pressure in the pipelines, just a little bit technical thing. I think CPHO norms, earlier there were some 12-meter pressure was required, now it is 25 meters. Pressure is there in the pipeline, then there is a chance that there will be leakages will be increased. So you need to ensure that the pressure doesn't build up during the night. When does pressure build up? When people are not using the water, especially during night. So these systems will ensure that, if the pressure is building up, then a particular valve needs to be opened through SCADA system. So these things can be automatized. What happens is कि हमारा manpower cost कम होने वाला है. Everyone knows that we don't have that much manpower. We don't have the luxury of that much manpower. So these things need to be technology के through. We need to find out where specific intervention of humans is required, and rest of the things need to be carried on in an automatic mode. So friends, these are some of the things which Pune Corporation and I'm sure many corporations will be using. Coming to the second part, once you have supplied the water, when you look at the circular economy, you also need to look at the treatment part of it. How are you treating the water? What technologies are you using there? So we have a agreement with the irrigation department in which they have said that you are lifting so much water, but out of this, certain amount of water needs to be given to the farmers, because everyone knows earlier the dams were built basically for irrigation purpose. So in that aspect also, in Pune specifically, we are doubling the treatment capacity. Right now, the capacity is close to 500 MLD, but our requirement is big, and big infrastructure project which has been supported by Japanese government through JICA. So that is going to finish in the next year, and by that time we'll be able to double our irrigation capacity. Once we double the irrigation capacity, the quality of water will definitely improve. The water we are going to provide to the irrigation, to the farmers downstream, the quality of that water will improve. We will also be exploring if some industrial use can be done. Small uses, obviously, everyone is doing, like watering in the gardens, on the dividers, and construction. They are everywhere being used. But bulk generation, bulk usage, especially for the cooling towers of new data centers or such IT parks. So that we are still exploring. But again, this is also all SCADA controlled. So you have everything in the control center, and anything which is a deviation from the trend, an alert comes up and you need to then explore the alert. Technology is one part. Without community participation, things are not going to have something called Jan. Just a second. It's not working. So there are two programs basically in that. One is Jal Sakhi program, which is basically community-based program in which we involve the women volunteers. So they go around telling the importance of water conservation, telling the importance of regular audit of water, giving the importance of metering. What is the benefit to the customer also? He'll get a regular good quality service if he pays the bill on time, if the water is metered. We also have something called Jal Chetna workshops, in which we are doing water literacy sessions across the wards. Because many times if you go to the slums and other areas, you'll see a lot of wastage of water which is happening. Also, there are these public dashboards in which we give the real-time data, like today Pune is using so much water. Today we are drinking, so many MLDs, just to raise awareness amongst the people that this is a challenge. This is something which not just the government, but the citizens also have to get involved and work with the government. Otherwise, it's going to be a lot of challenges. Everyone knows that we need to secure each and every drop of water. And there is a lot of pressure between the farmers and the urban usage. Because if you look at just specific last point, specifically of Khadakwasla, which is the dam which supplies water to Pune. So 29 TMC is the capacity of the series of dams. 21 TMC Pune city is using today. There is hardly any water left for farmers. And if this continues, there's going to be a lot of unrest, agrarian distress. And I'm sure this is a situation for all corporations in India. So these are the things we need to be aware of, together with citizens' participation, together with the help of technology. We need to invest heavily in this, so as to ensure that it's a secure and as the topic says, water resilient urban future. Thank you.
Thank you so much, sir. I request everyone to please give him a big round of applause. A couple of very important points highlighted by sir was that technology has its challenges, but still it will help to narrow down the areas where interventions are required. Very important. And secondly, community needs to be involved at every stage. Very important points. Thank you for highlighting those, sir.